Hi, we are back with the part 2 session for week 4. So here we will be discussing on today's other lecture, that is a part for solid conveying and solid storage. So let me present the concerned PPT for this session. I hope it is visible for everyone. Okay, so we can start the part. So again, I would like to introduce myself. I'm Smita and I am PhD PMRF scholar in Department of Chemical Engineering, IT Madras. So this lecture I am taking as a part of my teaching assistantship of Prime Minister Research Fellowship. So in this class we are going to discuss about solid storage and conveying. So let's start with the brief introduction part. So particulate solid or bulk solids are an assembly of discrete solid particles. They are interspreads within fluid, generally air. So while the interaction between the fluid and the particles may have considerable effect on their behavior of the bulk material, in that case of air as the interstitial fluid, the influence of the fluid properties become very negligible for the grain size larger than few hundred micron. So here we have to deal with some cohesive and non-cohesive particles. So these cohesive and adhesive forces also become less important compared to the particle weight beyond this size. And the behavior of the granular material is determined almost entirely by the normal and frictional contact forces between two individual grains. Now these particulate solids in the size range of zero point 0.1 to 100 micrometer are typically referred to as powder material. Further subdivision in terms of fine powder, superfine powder and ultrafine powder are very common. At this scale, the cohesion or adhesion due to van der Waals forces, humidity or moisture present, and the air drag become very important and cannot be ignored. So, in general, the properties of the solid in bulk will be a function of the properties of the individual particles, including their shape, size distribution, and one of the way of the particles they interact with each other. Thus, in addition to the size, shape, or density, hardness, and surface roughness of the particles, there will be small variations in moisture and prior loading or compaction history can lead to significant change in the bulk behavior. So, also due to the poor flow ability, fine and cohesive bulk solids often show much more complex behavior and such as time consolidation or caking behavior. So now let me focus on cohesive particles because this kind of terms we are going to use in further slides. So you have to have proper idea or understanding about this term. So cohesive particles are those which tend to stick or clamp together due to intermolecular forces that are van der Waals forces or electrostatic or capillary forces. These are being very significant compared to the particle's weight. Whereas non-cohesive particles are those where interparticle forces are negligible to their weight. So they behave independently and they can flow freely. So non-cohesive particles can flow freely, whereas cohesive particles tend to stick it with each other due to high molecular intermolecular forces. It is very important to learn about angle of repose when you are storing bulk of solid material or masses. So the size of the material affects the angle of repose. What is that? The angle of repose is nothing but the measurement generally tend to be more reliable for the non-cohesive and free-flowing and homogeneous material which is having a narrow particle size distribution. Just like oppositely they behave for cohesive and poorly flowing or non-homogeneous material. So larger particles have lower angle of repose, allowing for higher flow ability as long as they have uniform shapes. And for non-uniform particles, the angle of repose shows slight higher value, which explains the inability of the irregular shaped particle to flow. So, one aspect of the solid bulk properties is to know about their flow ability. That is important because when you are storing the bulk solid into some storage bin or hopper or silos, from there you have stored, but you have to also take out the material from the bag. So for that case, flowability of the material should be good. So that is related to the angle of repose. This angle indicates that how steep you can stack the material before it flows downward. It can range up to 90 degree. So it denotes that steeper the angle indicate that elements that pile higher before spilling and they are very cohesive in nature. That means they are very sticky. So they are very poor in flow. Okay, so there are some measures of uh, this angle of repose. See, this is the pile of the solid, and when it forms the angle with horizontal, this theta is the angle of repose. If the theta is very less than 30 degree, that is super free flowing material. But if it is working between 30 to 38, still it is free flowing. But cohesiveness start from 45 to 50 and greater than 55, it doesn't even flow. So the size of the material that also affects the angle of repose. Larger the material particle size, there will be lower angle of repose, allowing for higher flow ability as long as they have uniform shape. For non-uniform shape, the angle of repose have slight increased value, which explains inability of the uh, material to flow. Now we must have to go through what are the pressure acting inside the storage vessel or storage bin. So any kind of solid particles they also exert some, suppose this is your bin and there are some solid particles. Just like other liquid particles, these solid particles will also exert some pressure in all around, but these all pressures are not same, just like a liquid particle. Lateral pressure causes friction and this propagates to other particles due to interlocking properties. Therefore, the solid particles can not slide over one another until there is any applied force that reaches to the appreciable magnitude. Any kind of granular solid or solid masses, they permanently resist distortion when they it subjected to a moderate distorting force. When the applied force is large, failure occurs. One layer of the particle slide over another. Pressure, obviously, I told that this is not same in all direction in the bulk of the solid mass, and the pressure applied in the one direction may create some pressure in the other direction, but some in a smaller magnitude. And minimum pressure is always in the direction of the perpendicular direction of the applied pressure. So that is the normal pressure. So in homogeneous mass, the characteristics of the material is defined by a constant, that is K. It is nothing but the ratio of the normal pressure by applied pressure, and this constant obviously depend on the particle shape, particle interlocking tendency, stickiness of the particle or cohesiveness of the particle, and how tightly the material is being packed. So this constant is nearly independent of the particle size until the grain size becomes very small and material is no longer able to flow freely. This value K tends to 0 for cohesive particle because they are highly sticky and they have high interlocking attraction. So the flowability is 0, and it can be zero point 0.3 to zero point 0.6 for non-cohesive particles. Shear stress applied at the surface of any solid masses of particles is transmitted through a static mass of particles unless the failure occurs. So here that bulk density of the solid masses is less when the mass is packed very loosely and they permit interlocking grains to move past another. If the bulk density is very less, they can be free flowing. So here one um, interesting problem that we face during the storage of the bulk solid masses, that is agglomeration. So it is like a significant amount of the material when they are from particles smaller than 10 micron, or the particles deviate substantially from isometric form, it may inferred that the flow characteristics will be very poor. And if the particles tend to agglomerate, poor flow properties might be expected. So this agglomeration arises from obviously interaction between the particles, and as a result they adhere to one another to form big clusters. The main mechanism um, go that enhances the agglomeration, that is mechanical interlocking. This can occur particularly if the particles are long and thin, which in case large masses may become completely interlocked. Surface attraction. There are surface forces, including van der Waals forces, that may cause substantial bond between particles, and particularly where the particles are very fine, with the result that their surface per unit volume is very high and there will be high surface attraction. In general, freshly formed surfaces, such as resulting from particle fracture, due to particle fracture, there will be new formation of the particle surface, and that can give high rise to the high surface forces. Plastic welding is kind of like when irregular particles are in contact, the forces between the particle will become very extremely small surfaces and very high pressure developed that may rise to plastic welding. Electrostatic attraction, that particles may become charged as they are fed into equipment, so significant electrostatic charge may build up, and particularly fine solids. So effect of moisture, as I already told, that effect of moisture, they become too much sticky to each other, and there will be increase in the surface tension between the particles. Also, it may dissolve a little bit of solid, which also acts as a bonding agent or subsequent evaporation will take place. Temperature fluctuation also brings some changes in the particle structure and greater cohesiveness. So these might be the cases due to which the agglomeration occurs and the solid particles may behave very poor in flow. Now we also had to understand that what are the hazardous conditions when we are dealing with bulk solid uh, masses. So the part is segregation. Although the fluid mixture tend to remain homogeneous, mixture of the solids are prone to segregate due to the difference in the particle size, shape or density that we know, right? For example, shifting segregation occurs when the smaller particles move through a mixture of the larger particle, causing fines to accumulate in the center of the storage vessel. So these are the very smaller particles, and the coarser materials are rolled down at the uh, wall of the or at the periphery. If the bulk solid is caused as a rectangle reactant or catalyst in the downstream process, so it will be very unsafe practice if the particle size in such kind of storage, if the particle size distribution get disturbed. So obviously, because that is dependent on the reaction kinetics, surface area and other thing will change. So we need to ensure that how the materials are being stored, because if there is this kind of segregation is happening inside the vessel, so we need to mix it again. Dusting. If sufficient amount of material becomes dispersed in the air, any kind of serious fire explosion or any kind of other explosion can happen. So if an ignition source is present and oxidant is also present, so obviously there will be chance of minimum explosion concentration. If it is above, then the combustion will take place rapidly and there will be flash fire. Next is flooding. The discharge rate from a storage vessel is typically controlled by a feeder. It can be screw feeder or belt feeder. So when entrained in air, a fine particle powder can sometimes behave like fluid, and since the feeder usually handled is designed to handle solid materials rather than fluid particles, discharge become very uncontrollable and can be choked, or it can be hopper can completely become empty. So obviously these safety problems are occurred when we don't deal the solid materials with proper knowledge. And other hazards that may follow up, that is non-uniform flow. An improperly designed hopper or feeder can have an unpredicted discharge rate. Flow may become erratic and stop entirely. If solids discharged from a hopper are reactive and act as a diluent, so there will be downstream processes, they may hamper a lot. Now, the charge accumulation when insulating materials such as plastics are handled in silos, bins, or hoppers, they cause problems as blend non uniformity and unwanted agglomeration. So here we can see like material addition to the surfaces of process equipment, and in extreme cases there might be fire or explosion that can also happen. The severity of the hazard with associated with bulk solid handling depends on their flow patterns inside the hopper and silo or bin. So flow pattern or flow ability to uh, learn about it is very important to avoid the hazardous conditions. For example, when the two silos come in contact, electrons may become separated from atoms on the surface of one material and they may be transferred to the atoms on the other. So they create a positive charge on the electron donor and negative charge on the electron acceptor. So this kind of mismatch can happen when there is no proper handling of the solid, bulk solid. If the material is insulating, it will remain charged when the materials are separated. Even if the substance is an electrical conductor, it may remain charged if it is remaining isolated from the ground. The amount of charge generated depending on the chemical composition of the material, how it is introduced into the vessel and what is the electrical properties and the particle size. The magnitude of the charge also depends on the work done on the material. Hence, the flow pattern in which the bulk solid travels inside the vessel is very important to understand this kind of thing. Now we will discuss about the storage part of the bulk solids. So there are basically three kind of arrangement that we follow. One is a storage bin. These are the silos and these are the simple hopper or feeder that we can see. This is hopper, and at the end there will be feeder and there will be equipment. So hopper and bin frequently refer to smaller and wide storage vessel for solid, bulk solid, whereas silo refer for very tall and several of tons of material can be stored in silos. So they are basically cylindrical shape or rectangular shapes made of concrete or metal. Hopper is a small vessel with sloping bottom. These are sloped bottoms used for very temporary storage before feeding to the process equipment. So there is always friction present between the wall and the solid grains. Frictional force at the wall tends to offset the weight of the solid and reduce the pressure exerted by the mass on the floor of the container. Vertical pressure on the vessel floor or the packing support is much smaller than the exerted by the column of liquid of the same density and height. Actual pressure from the solid depends on the value of the material characteristics constant for a specific solid and frictional coefficient between the solids and container wall. Also, it depends on the way of solid is placed inside the vessel. If the height of the solid column is greater than 3 times of the diameter of the container, any additional solids have no impact on the pressure at the base of inside the vessel. However, the total mass will increase, more solids can be added. Unlike the case of the liquid, for granular solid, higher pressure um, does not increase the tendency to flow. Rather, it causes more grains to pack tightly and they may cause poor flow ability. So we can now discuss about the flow patterns in different storage vessels. First one we will discuss mass flow. So here we can see these are the different flow patterns. This is the axisymmetric flow, this one is symmetrical flow, and this one is completely non-symmetrical flow. So stiffness of the wall and the frictional coefficient between the solids and the walls play a very vital role for solid flow pattern. There are three flow patterns in any kind of symmetrical geometry. One is mass flow, funnel flow or expanded flow. Mass flow, when in mass flow what happens that entire bed of the solid become always in motion when the material is about to discharge from the outlet. This behavior prevents the formation of any kind of stagnant material inside the vessel and any kind of formation of rat holes. Affords first in first out flow sequence and ensure more uniform velocity profile during the operation. Material surface in the cylinder descends uniformly and flat. No stagnant zone is found. Shear occurs along the wall and residence time distribution is also very narrow. segregation is also minimized here. In order to achieve mass flow condition, two conditions must be met, that is, sloping of the hopper walls must be steep enough to have low enough friction for the particles to side along one another, and outlet must be large enough to prevent any kind of arcing situation. Depending on the hopper shape and associated flow pattern, the mass flow bins are classified into conical or axisymmetrical, wedge or chisel shaped, that is symmetrical and non-symmetrical plane flow patterns. So mass flow requires steeper hopper that I already discussed, and obviously smoother walls, so that they provide low wall friction and larger wall angles to the horizon, that is steeper. So vessels should be taller and should have liners. Higher structural growth on the walls during discharge, that is more uniform but often higher lateral stress than the funnel flow. So a mass flow hopper has a first in first out flow sequence that minimizes shifting segregation effect. That is already discussed, right? What is segregation effect? Because the entire bed of the material is in motion, the velocity of the solid in the vessel designed for mass flow is much lower than the funnel flow hopper. Therefore, typically reducing the amount of the static charge generation. Now we will discuss about the funnel flow. Here the main problem is there is stagnant material formation. The materials flow first from the central line and forming a channel to the outlet while a stagnant zone remains along the walls. Often this is called core or tunnel flow. In funnel flow, only a portion of the bulk solid above the outlet is in motion, while some of the materials remain stagnant at the periphery as the material is discharged. Funnel flow occurs when the sloping hopper walls are not steep enough and low enough in friction for the particle to move along one another. Under these conditions, the particles slide on each other rather than on the hopper wall. An internal flow channel develops. Funnel flow can cause erratic flow and exacerbate segregation, reduce the usable capacity of the vessel, allow the particle degradation because they can form caking or spoilage of the particle can occur. And depending on the vessel size, they can induce high load on the structure and the downstream equipment due to collapsing of rat holes and eccentric flow channels. So here the fine powders will flood if the rat holes collapses and if the fresh material is added to the vessel. Velocity of the solid in the flow channel of a funnel flow vessel can be very rapid, and especially they can be in very rapid in the conical hoppers with a flow channel diameter which is slightly larger than the outlet diameter of the funnel diameter of the storage bin. Compared to the mass flow bins, the number of contacts and the frequency of contacts between the individual particles are very high in case of the funnel flow. So the potential for static charge accumulation is also higher. Furthermore, when the bulk solid is insulating and the stagnant material along the periphery of the vessel will limit the effectiveness of the bonding the charge of the vessel wall. If a rat hole collapses, the solids can become entrained in air inside the empty channel and creating an atmosphere conducive to a dust explosion as well. Funnel flow occurs when the hopper angle is not steep enough or there is wall friction too high to mobilize the material particles along the wall and large diameter bins with smaller outlets. So these are the cause for funnel flow. Now we talked about arcing and rat holing. So these are the kind of obstruction that we follow when we want to discharge the materials from the storage bin. So this is the case where no obstruction is found. This is a smooth operation. But this arcing occurs. It is a stable obstruction for the solids formed directly above the outlet and blockages the discharge. It is happening when the outlet size is too small for the material's flow property, more common with the cohesive particles or the stickiness, and there will be interlocking between the coarser particles. Rat holing situation is very common for funnel flow beams. If the material is cohesive and very poorly aerated, stagnant zone doesn't even move. Once the core empties, flows stop even though there are much more material present in the silo. So these are some problems we need to design the silos or design the storage vessel in such way this kind of obstacle can we can avoid. The next part is expanded flow, which is another flow pattern that is found in the storage vessel. This is nothing but the hybrid flow pattern where we can get funnel flow as well as mass flow uh, in the same hopper. So the lower mass flow section is sized so that the channel forms above can not remain stable and forcing the entire cross section to move into the bottom hopper. An expanded flow design requires an upper funnel flow section. So this is one the funnel flow section and this one is the mass flow section. First come first out basis. Efficient flow pattern we can get an expanded flow silos. They stockpiled are recommended for storing large quantities for non-degrading materials and modifying existing funnel flow silos to correct problems caused by arcing or rat holing or flashing. So the next part is we are going to discuss about the bulk solid conveying. So here we can see that there by any kind of rail or truck we have transported long distance solid particle. Now we feed to the this kind of conveyor and we are storing it in the separate place. So this is the purpose of having this conveyor built or chain conveyor or any kind of conveyor. So let's start with so a conveyor is a mechanized device to move materials in a relatively large quantities between a specific location over fixed path. Choice of the equipment depends on the shape and size, nature of the material to be transported, also the capacity that we want to transport, also how is the arrangement like horizontal, vertical or inclined transport can be possible. Also the distance of travel. So for long distance solid travel transport, we generally prefer rail, road or ship medium. For any kind of short distance solid transport, we use conveyors. They either can carry solid or they can drag the solid through the channels. Sometimes conveyors are found to be more economical than the road or rail medium. So we also have vertical conveyor that is also known as elevator. So conveyors can be classified in different ways. So let us classify the thing. It can be classified type of the product being handled, unit load or bulk load, location of the conveyor, in floor or on floor or overheaded, whether loads can be accumulated on the conveyor or no accumulation is possible. So here mechanical conveyors are belt, chain, buckets, screw and apron conveyor. So mechanical conveyors are typically 10 to 20 kilometer distance transportation. Pneumatic conveyor is like pipe conveyor for 600 to 100 kilometer distance transportation. So here we can start with the belt conveyor. Belt conveyor consists of the endless flat and flexible belt which can have sufficient strength and made of fabric, rubber or plastic, leather or metal. So which is laid over two metallic flat pulleys at two ends. This is the belt and they are driven by the end two pulleys. So the range of sizes which may be handled is limited only by the width of the belt. So they can be handled for a wide range of capacities over long distance than possible with other types of conveyor system. Belt conveyor operate in one horizontally or with inclination depending on the frictional property of the material. For changing direction of the material being conveyed in horizontal plane, more than one conveyor belt will be required for that case. Conveying capacity of a conveyor can be controlled by changing the belt speed. Metal or a special belt can be used to carry hot and abrasive and some reactive material. Advantage is we have less manpower, it is more economical, low power consumption, and there will be low maintenance cost as well. And multi-point loading is convenient. Unloading and loading, it also follows simple arrangement. But disadvantage is we cannot do vertical transportation by this simple belt conveyor, and also it is not suitable openly to use belt conveyor for dust particle or very fine particles. So generally we prefer closed uh, chamber belt conveyor system. Here in this picture you can find. There are some arrangements for belt conveyor, so you can just go through that. We can arrange two belt conveyor in such way that you can go horizontally then ascending order. So you can go through this picture, and typically belt conveyor having head pulley and tail pulley, and there are some suppose these are some belt rubber belt and carry idler are there, and they also this is the take up pulley is there. So this is the typical arrangement for the belt conveyor. Next one is the chain conveyor. You can see these are the chains that is rotating and thus the material is being carried over. So a chain conveyor transfers material by means of moving chain. It is applicable for heavy and abrasive product transportation. A conveyor chain have plates, blocks and bars attached to it and which are designed to fasten and push and drag the object in its own way. It can be generally easily installed with minimum maintenance. Advantage have like the chain easily wrap around the sprockets with a small diameter and drive is positive. No spillage takes place between the chain and the sprockets, and also the chain stress is also little. Disadvantage is high weight, high initial cost, higher maintenance cost. Also running speed is limited. Apron conveyor is a type of chain conveyor which consists of carrying surface which is series of plates and this kind of which is called apron. It is attached to the link of chain through the cleats. Next one is a screw conveyor. Screw conveyor, these are the screw blades and this is the rotational shaft. It will rotate. So here it moves, material moves forward direction in the tube from feed point to the discharge, while there is helical screw that rotates. The force that material does not rotate with screw conveyor blades is the material's own weight and the frictional resistance that the material doesn't rotate with the only the uh, screw conveyor. Using the screw conveyor, fine and pasty solids and abrasive, non-abrasive material can be conveyed. It can be operated at positive as well as negative pressure, and it can be also operated horizontally or vertically. But it consumes very high power for its operation. And here these are the mechanism that pushing method. It spiral blades that push forward and commonly used at the bottom of silos. Tightly packed material conveying requires very high friction and static pressure. Variable pitch screws are often used to improve the discharge efficiency. The next mechanism is centrifugal induction method, where high screw speed and the steep inclines centrifugal force that will dominate the gravity, allowing loose materials to move effectively along the conveyor. And gravity sliding method, that as a low screw speed, gravity dominates and the material slide down the screw surface loosely with minimal compaction.